Hello and a warm welcome back to Mr. Midgley's YouTube channel. We're looking at the second in the Coffee Over Chemistry series and we have some fantastic questions. First one I'm going to pose to a lovely student at our school who shall remain nameless. Christian.
Yes.
Why don't animals have wheels?
Well, wheels are really only effective on flat surfaces in a sense, because if you take a wheel into sort of a mounty area, it won't be effective, just like how someone in a wheelchair can't really go upstairs. So thus animals won't really have a good use for wheels because they're not usually in flat terrain most of the time. So for example, they'll be in rough terrain where wheels aren't effective. And there's also sort of a wheel, because we're talking about an animal, it won't be powered by an engine. And because of this, the wheel has to have an axle. And there's no way for an animal to sort of grow a wheel, then detach it from its body, and also have it connected to its body through an axle at the same time.
Love it. Thank you very much for your response, Christian. I'm just thinking about the penguin. Of all animals in the world, wouldn't the penguin be fantastically better with wheels? So therefore, doesn't evolution suck?
Sure.
Thank you for your response, Christian. Well done.
Hi, Richard Thornley here. Oh my God, I think he's in my hair. So, carbon with 6 gold atoms, 5 minutes to go, and pentavalent carbon compounds have recently been discovered. These chemical curiosities are of no commercial value, apparently. Was their discovery a waste of resources?
Well, in the future, new findings and methods could be updated, and this pentavalent molecule could be used in the method, so shouldn't be forgotten. But
yes, I guess the classic example is Buckminster fullerenes, where C60, etc. And we are still looking for wider applications for them. So would you happily sign off your inheritance on the pursuance of knowledge in chemistry without any commercial value?
it might pay off in the future.
I like your gambling attitude to that one. Thank you, Miss Kelly. Thank you very much.
I would like to say that chemistry and finding new areas in chemistry is fun, and life is about fun. So even though those inventions or like maybe new elements in the periodic tables are useless and wastage of resources, if you got entertained, then good.
Right, welcome Miss Aria to your university interview. Could you tell me something about the role of beauty in chemistry, please?
I think the role of beauty is really important in understanding and appreciating chemistry as a science, because if you appreciate the beauty in the nature of, for example, the experiment or the mechanism, then you're a lot more interested in studying it further and you're more appreciative of the mechanism. And examples for this, like the role of beauty could be extremely simple, for example, the color of an experiment or the smells that it produces, or it could be more complicated, such as the mechanism behind it. But I think that appreciating and understanding this side of beauty is really important in appreciating the subject.
I'd totally agree. I think the elegance in chemistry is the thing that makes it so attractive as a place to study. Thank you very much for your response, Miss Aria. Well done. Thank you.
How do you know when an aspect of chemistry is finished and is no longer worthy of research funding?
I think we can know when the research is finished, and that is when the chemists intuitively think that there's no longer development for the research, because when you discover something new, the intuition is the most important thing. Therefore, even though there's no logic, but if scientists or chemists believe that there's something that they can do, they should pursue the research and develop more. But even if they don't have any intuition and also logic, they should not research more and they should finish the...
I love that response, Ms. Aki-san. Thank you very much. I think that the role of intuition is certainly a massive aspect in the role of a scientist in this day and age. Thank you.
Funding should never stop entirely, but there are certain aspects of chemistry that probably have more research that has been done, and so less funding could be dedicated to specific aspects of chemistry. But I don't think any aspect of chemistry is not worthy of research funding.
In IB chemistry, you've looked at how line spectra are produced when an electron jumps down to a lower energy level, releasing a photon of light. But you've not examined phosphorescence, fluorescence, chemiluminescence, or triboluminescence. All four of those involve different aspects of creation of this kind of line spectra. Phosphorescence involves forbidden electronic transitions. Can you suggest some of those transitions and explain why they're forbidden? Fluorescence turns UV light into green light in fluorescent vests. How could that be possible? I thought every time it jumped up, it jumped down the same amount. If UV goes in, then doesn't UV just come out? Now I've got an email. Triboluminescence is where you crunch something and it gives out light. And chemiluminescence, well, that's like a glow stick. There was no 5,000 volts zapping a gas in an enclosed tube there, or no heating it up in a Bunsen burner to look at the spectra. Can you suggest how chemiluminescence works?
Nameless student, Mr. Martial, welcome to your university interview. Why don't plants need kidneys?
Well, I'm no expert on the role of kidneys in the human body. However, from what I know, they dictate the removal of waste and filtering of waste in the human body and the bloodstream. And I mean, intuitively, plants don't have a bloodstream, therefore wouldn't need a kidney or kidneys. As well as that, I think that looking at a plant holistically, it seems that they have a much better exchange with their environment than, let's say, a human, and therefore there's no need to concentrate all of the waste in the way that the kidneys do to then all be expelled together. I think they're able to release waste in different ways.
So it's plant design, if you like. It's architecture, which makes it more suited to its environment than perhaps humans. Is that what your conjecture is, Marcio?
Well, yes, yeah.
Okay, can you think of anything better than a kidney for a human being to deal with its waste functions?
Better than a kidney? No, that's like imagining a color. I don't think that's possible.
What a beautiful analogy. Thank you, Mr. Marcio. Mr. Stewart, what do you think is the most important discovery in the whole of science in the last 100 years?
I would say it would have to be plastic, because it ultimately has led to entirely new fields of science being developed. It's also enabled us all scientists to explore and learn more at an unprecedented rate.
This video was done on the last lesson of term, and students were not prepared. They answered these questions cold, so you can have a judgment about them. I think they all deserve a very much well done on making those responses reasonably intelligent and well thought out. Of course, at 4 minutes and 55 seconds, there's the opportunity for you, dear listener, dear viewer, to answer Mr. Thornley's question. So, type your answer in the comments box for a chance to win a free Mr. M for Chem mug. How great is that? Okay, best of luck with your studies. Enjoy those university interviews. Remember, most questions will be around what you already know. They want to know your depth of knowledge of what you've done and the facts that you want to learn some more. And you can talk about it in a reasonably intelligent fashion. I'm sure you'll be fine. Thanks for watching. As always, smash that subscribe button. Thank you very much indeed. Bye-bye.